Alright, so this question reads, solve the following equation for the matrix X. We're trying to figure out what X is. Now let's just go ahead and name all of our matrices using some variables. So this is A, X is X, this is B, and this is C. There are a few things you should know. So right now, we have AX times B is equal to C. What we can do here is say AX is equal to CB to the negative 1. Because our B is on the right side of our left side, it's going to be on the right side of our left side too. So because here there's a multiplication and there's no such thing as matrix divisions, we take the inverse of it and we multiply our C times the inverse. Now what we're going to do next here is we are going to take our AX is equal to C times the inverse of B, and we're going to do a similar thing with X. So X is equal to, let's call this new matrix D. X is going to be A negative 1 times D. So again, we're going to take the inverse of A and multiply it by D. But see here, A is on the left side of the left equation. It's going to be on the left side of the right side of the equation as well. So I'm just going to go ahead and write these up here. Okay, so these are our steps that we're going to do. Step 1 is this one, and step 2 is this one. Let's go ahead and find the inverse of B. So we have 2, 1, 3, 4, and we're going to try to find the inverse. There's another equation you should know. To solve A to the negative 1 of a 2 by 2 matrix, we do 1 over the determinant of that matrix multiplied by D, negative B, negative C, A. So let's just do that. 1 over the determinant. Well, to find the determinant, we multiply these two together and we subtract these two. So we have 4 times 2, which is 8, minus 3 is equal to 5. That's our determinant. And now D minus B minus CA, we're just changing the order of our matrix. So here we're going to have 1 over 5 times, if our matrix was in the form A, B, C, D beforehand, D is this bottom right number, so it's 4. B stays the same, but it turns into a negative, so it's negative 1. Same thing here, it's negative 3. And the top left becomes the bottom right. So if we do 1 over 5 times this matrix here, we get 4 out of 5, negative 1 out of 5, negative 3 out of 5, and 2/5. So the inverse of B is this 2 by 2 matrix here. The next step is going to be multiplying C, matrix C, by B. So let's write that out as well. We have matrix C, which is 2, 5, 1, 0, 0, 1. And we're going to multiply this by our inverse of B. If you remember how to do this, we take our first row and our first column. We take the first number, first row, first column, so this number here, and we multiply it by this first number, and then we add this number times this number. So our first number up here is going to be 2 times 4 out of 5, which is 8/5. So we have 8 out of 5 plus 5 times negative 3 out of 5 is negative 15 out of 5, which is 3. And now we move on. So second row, first column, so 1 times 4 out of 5 plus 0 times negative 3 out of 5 is just 4/5. And for the last one, we have 0 times 4/5 plus 1 times negative 3 out of 5, which is negative 3 out of 5. So for the second column, we're going to do these two numbers and these two numbers. 2 times negative 1 out of 5 is negative 2 out of 5 plus 5 times 2 out of 5, which is 10 out of 5, and 10 out of 5 is 2, so plus 2. Second one, so second row, second column, 1 times negative 1 out of 5 plus 0 times 2 out of 5 is just negative 1 out of 5. Here we have 0 times negative 1 out of 5 plus 1 times 2 out of 5, which is 2 out of 5. So let's rewrite this up here. And this is going to be our matrix D, because C times the inverse of B, we called it D. Okay, we're almost done. So for the last part, we have X is equal to the inverse of A times D. We already know what D is, so all we have to go ahead and do is find the inverse of A. I haven't actually talked about this method, but we're just going to go ahead and use it. So we're just going to write matrix A. And because it looks pretty similar to an identity matrix, what we can do is draw an augmented matrix of it. So here we have A on this side, and we have its identity matrix on this side. So it looks like 1, 0, 0, 0, 1, 0, 0, 0, 1. It's just a matrix with ones down that diagonal. And all we're going to do is we are going to take A and we are going to do some row operations to make it look like I. So what I mean is, here our 1's good, 0's good, 0's good, this is good, this is good, this is not, we want this to be a 0, this is good, we want this to be a 0 as well, and we want this to be a 1. So we can start with this one right here, because we always like to go column by column. So our new row 3 is equal to old row 3 minus row 2, because 1 minus 1 is going to be 0. And now we're going to do this row operation on the entire matrix, so on this side and on this side. So what we get is row 1 doesn't change, it's 1, 0, 0, we have dash line, 1, 0, 0, 0, 1, 1, 0, 1, 0. Now for row 3, we do the old row 3 minus row 2, 0 minus 0, 0, 1 minus 0, 0, 2 minus 1 is 1, 0 minus 0, 0, 0 minus 1 here is negative 1, 1 minus 0 is 1. We're going to take this and we want this to become a 0, so we are going to do our new row 2 is equal to row 2 minus row 3, because 1 minus 1 is going to be 0. So again, nothing's going to change for the top or the bottom. We have, sorry, for the top row or the bottom row, so we have 1, 0, 0, dash line, 1, 0, 0. Here, row 2 minus row 3, 0 minus 0, 0, 1 minus 0, 0, 1 minus 1. Made a mistake. 1 minus 0 is still 1. 1 minus 1 is 0. 0 minus 0 is 0. 1 minus negative 1 here, that changes, and that is 2. 0 minus 1 is negative 1. Then nothing changes here. So 0, 0, 1, 0, negative 1, 1. Now this here on the right hand side is our inverse. Now the last step is just to solve this equation. X is equal to the inverse of A times D. So let's have the inverse of A, which is, you just said this, 1, 0, 0. 0, 2, negative 1, 0, negative 1, 1, multiplied, matrix multiplication, negative 7 out of 5, 8 out of 5, 4 out of 5, negative 1 out of 5, negative 3 out of 5, and 2 out of 5. So I just moved it up here because we're going to need some room. We take the first row and the first column. So we have these two. We have 1 times negative 7 out of 5. Let's rewrite this. This is our final matrix. This is X. First row, first column, 1 times negative 7 out of 5 is still negative 7 out of 5, plus 0 times 4 out of 5, plus 0 times negative 3 out of 5. Those don't do anything. Now our second column, first row, 1 times 8 out of 5 is still just 8 out of 5. 0 times negative 1 out of 5 plus 0 times 2 out of 5. Those don't do anything. Now let's take our second row, first column. Here we have 0 times negative 7 out of 5 plus 2 times 4 out of 5, which is 8 out of 5, plus negative, here we have negative 1 times negative 3 out of 5, negative 3 out of 5. So that is 8 out of 5 plus negative negative is just plus 3 out of 5, and that gives us 11 out of 5. So we can write that here. Now second row, second column, 0 times 8 out of 5 is 0. 2 times negative 1 out of 5 is negative 2 out of 5 plus negative 1 times 2 out of 5, negative 2 out of 5, which is negative 4 out of 5. So we have negative 4 out of 5. We're almost done. Last row, first column, 0 times negative 7 out of 5, still 0. Negative 1 times 4 out of 5 is negative 4 out of 5, plus 1 times negative 3 out of 5, so minus 3 out of 5, minus 4 minus 3 is equal to minus 7 out of 5. And last but not least, we have 0 times 8 out of 5 plus negative 1 times negative 1 out of 5, which is 1 out of 5, plus 1 times 2 out of 5, which is 3 out of 5. So that was a bit of work, but we have figured out what x is.